Kia ora. Right, trigonometry, straight into it. No mucking around. Hopefully you've had a bit of an introduction. If not, let's quickly go over the relationship between a triangle, its sides and its angles. Yep, we can use trigonometry to find one of them if we've got two of them, I think. Let's hope. So, firstly, let's label the sides of this triangle if we're going to put it into our so, ka, toa. Right, angle. Opposite, the angle is the opposite. Cool? Okay, then adjacent. So the angle is the adjacent. So the long side must be thy hypotenuse. Cool? So we've got A, O, and H. Cool. We've got O, H, A, H, O, A. So we're good to go. Cool. So to calculate, let's say the H, so the hypotenuse on this triangle, we need to select one of our triangles. We've got so, ka, toa. We need to identify the parts that we have of this triangle and the part we want to find. Okay, so we have the angle, which in this case, in any of these, is going to be sine 20, cos 20, or tan 20. But then we need to figure out what side we want to figure out. So we have side A, so we need to use either these two. And then we need to know which one we're wanting to find. So it's H. So obvious down here. Cool. So we need to work it out. Now, like I've shown some of you before, if you haven't seen it, using this basic triangle, it's quite straightforward. So if we've always got the angle, we're either going our adjacent divided by our cosine of the angle, okay, equals the hypotenuse, or it's cosine of the angle times hypotenuse equals adjacent. So in this case, it's going to be 3.55, correct, divided by cos, and our angle is 20. Easy. So that equals our hypotenuse up here. If we do that quick calculation, it should give us this length. Now, I'm going to quickly do it on my computer. And we get 3.778. Easy. Cool. So, again, if we want to go over here and figure out, I'm getting kind of caught behind all this drawing. If we want to find O, we need to then figure out which triangle we're going to use. So let's go to this one, yeah? We've got A, we want to find O, we've got the angle, cool. So what are we going to do? Right, getting right down here. We are going to go, let me do it on my calculator quickly first, just so I know the answer before I show you guys. Cool, okay, so we're going to go O equals 10 times adjacent. We've got the angle, we've got the adjacent. We want to find the opposite. So opposite equals 10, 20 times adjacent, 3.55. Oh, sorry, the pen seems to be running out. Cool, which equals, quickly on my calculator here, 1.292. I think that's what I got. Oh, look at that, right, cool. So feel free to give those a go at home, just to check that you're getting it right. Cool. So now I want to talk about how it relates to building. Basically, this is great maths. We know it. We can do it on a piece of paper, but we need to transfer it into the real world. So my example today is going to be working out the common rafter length. Now, over here we have a small kind of section, you could call it, of how a common rafter would look. So common rafter is the main sort of member supporting the roof that runs from the ridge down onto the top of the load-bearing external wall. And then we have this part which is the overhang. This part, high-vis isn't doing me much good today. So we really need to look at how to find this overall length, from top to bottom. Okay, it's going to be handy and it's going to make things a lot faster on site. So we need to create triangles. We have to go back to this side. Okay, building, there's a lot of triangles. You'll find that out. but we need to create a big triangle. So it's very, very simple. We can create a triangle from this point right here, or we could calculate a triangle from this point here. So if we're building a house on trade fit, our common overhang is 600 millimeters, so 0.6 of a meter. Correct? Now, luckily on this example, I used the actual run, so remember half the span of the building. I used the run of our building that we're using on trade fit, which is 3.55. So our overhang from there to there is 600 millimeters, and then our run from our outside wall to the center point of our building is 3.55. Gosh, that was a shocking 3. Hopefully you can read it there. Excellent. So now we have our overall run for our triangle. So it's not going to be just as simple as this size. Yes, we could calculate this length, but what I'm trying to show you here is that we can calculate an overall length and work with a full triangle. So now I'm going to draw the triangle. Let's go with pink. Yep, we've got blue, green. Yep, let's go with pink. So we can draw a triangle from here all the way through to here, and we can go up to here, and we can go down the top of that rafter to there. Now, this angle is going to stay the same. We're going to keep it at 20 degrees. Now, hopefully it's not getting too messy here, and you are following me. So there we have it. We have created a triangle. Doing some basic addition, we can add these two up. So 3.55 plus 0.6. Okay, so grab your calculator if you're not quick on the simple addition. 3.55 plus 0.6. Yep, 4.15. Cool. So we have our overall run is 4.15. Cool, and we have 20 degrees. We now can work out our common rafter length. Now, don't take this as a complete common rafter length. We do have a minor issue up here at the apex, which is what we call shortening. Now, I'm going to go over that very shortly, so bear with me. Now we can calculate. So, calculator's out, we can figure out, right, we want to work out this, so we are going to use our cos triangle. So we're going to go 4.15, 3, keep writing 3s, 4.15, yep, and what are we going to do? We're going to divide it by the angle, cos the angle, so cos 20, so 4.15 divided by cos 20 gives us 20 equals 4.416. Cool, so that's our common rafter length. So common rafter, and then the length is 4.416. So we can calculate that long point of that rafter to the short point of this rafter is 4.416. So using our run and then our overhang, adding them together, and then using that as our whole overall run, we are then able to calculate our common rafter length. Now, I'm going to see if I can fit this in here, but calculating our shortening. So it's a little bit tricky to see on here now, but our common rafter butts up to our ridge board or ridge beam. Okay, so what we have to do is we have to create a little triangle right up in this area to be able to take off the half the width of that ridge beam or board. to reduce it down to our actual common rafter length. Now, to do that, we need to draw another triangle. So I'm going to go to blue now. It seems to be a popular colour, not. We're going to draw a little triangle. So if I start by drawing my ridge board, and let's say my ridge board is 45 mil. And that's how wide it is. So 22.5 would be half of it. Now, the reason I need half of it is that's because I've split the building in half. So my center line of the building, so half my span, my run, is going to come directly through the middle of that ridge board or ridge beam. So I have to half the width of that. My rafter is coming in here somewhere, if my blue pen was to work. Hopefully you can see that. No? Okay. Back to pink it is. Oh, I'll try one of these fat ones. That'll be fun. There we go. So we have our rafter come up here. So this is our common rafter. Oh, the board's moving. That's spinny. We need to work out a little triangle here to figure out the length. And we need to figure out this length. So if I come over here, and I'm going to write in blue, and I'm going to use this triangle, is down here our run of the triangle is going to be 22.5. Our angle is going to stay the same. We do need to find this to then be able to subtract it off that overall common rafter length to get our actual common rafter length. So, bear with me. We need to do the maths. Getting the calculator out. I'm going to figure out, right, we've got AH, we're going to use cos. So we're going to go 22.5 divided by cos of the angle, so cos 20. 20, it's going to be 23.9, so let's say 24 millimeters. Cool. So that is our shortening. We just found, so on the big triangle, we found that distance, which is this distance here, which is our shortening, is the distance we need to subtract, which is half the ridge beam or board, down to the point where our common rafter actually starts. So if we take our common rafter overall length and we minus our shortening, which is 24 millimeters, we get our actual common rafter length. So let's do this on a calculator just so I don't muck it up. 4.416 minus 24. No. I've got to go because I'm doing this in meters, we need to change that, don't we? So 24 millimeters in meters is 0.024. Gives us an actual common rafter length of 4.392 meters. Boom, done. Done. Yes, I've done. You can't even see me behind I was writing. Wish I was a bit taller. Maybe I'll come in the middle of the triangle. Hopefully you followed that. If you didn't, feel free to ask your tutor. Yeah, ask them some questions. Ask them if I'm actually teaching the right thing. Of course I am. Okay, guys. Thanks, and may see you for another one of these.